Hi, I'm Laura Serpa. I'm a professor of geology and geophysics, and I'm going to be talking to you today about plate tectonics and plate boundaries, and in particular we're going to talk about ridge transform boundaries in oceanic crust. So this is our scientific device. As you can tell, this is a rather complicated thing to construct. What we're looking at is a ridge in an oceanic system. This is a divergent boundary. You can see magma comes up and spreads apart, leaves the ridge axes. It gets lower in elevation as it moves away. And I have two of them, and they're separated by a transform plate boundary. Okay, so what's happened to this transform plate boundary is that material's moving in two different directions away from these ridges. Now, if we look at these things in terms of when the magma comes out and cools, it's coming out at the same time at both of these boundaries. So they have the same age. And so I'm going to put a little red sticker on each point that has the same age. We're going to see what happens to them. As then this plate boundary evolves, this divergent boundary, you can see that these materials of the same age start moving towards each other in this area. So this plate's moving that way, this plate's moving that way, and as time passes, they get closer and closer to each other. Now let's take a look at another block of time. So these green dots are all the same age, and they're younger than the red dots. So what happens as this thing evolves? The first thing that happens is, you can see here I've got a red dot across from a red dot. Now we've got a material of the same age passing each other, and if I'd done this well, they'd be the same elevation. And as this continues, you can see now that I've got older material next to younger material, and same thing here. They continue to pass, and eventually you come out here where you've got material that's younger next to material that's older, but they're not going to change in terms of that. They're going to stay next to each other all the way out. These are the fracture zones. They're not faults. They're not actively moving relative to each other across the zone, but we can still see them because there's a difference in elevation because of the difference in ages. So we've now looked at this very sophisticated scientific equipment where we've been able to demonstrate how the plate motion occurs across a transform plate boundary and changes into a fracture zone once it passes the two ridges that it separates. If you go and look at a map of oceanic crust, you're going to see the ridges and the transform boundaries and the fracture zones clearly expressed. So I hope this has helped you understand how the system works.